Our solar system isn't just made up of planets and the asteroid belt, and it certainly doesn't end with Pluto. Far beyond all of those familiar objects, at distances that stretch the limits of our imagination, lies one of the universe's greatest mysteries, the Oort Cloud. No one has ever laid eyes on it directly. There are no photographs, and we don't even know its precise location. But most of the comets that streak across our skies in dazzling displays of light are believed to come from this very place. The Oort Cloud is a theoretical, spherical shell made up of trillions of frozen celestial bodies, completely surrounding the Sun in every direction. According to calculations, this distant zone could extend as far as halfway to the nearest star, Proxima Centauri. Hey there, everyone! So, why are scientists so sure that this mysterious cloud really exists? How do they think it formed in the first place? And deep inside it, could there be something far more intriguing than just ice and rock? Welcome back to our channel. Today, we're setting out on a journey to the outermost edges of the solar system, to a place where hard science and wild theory begin to blur. The edge of the solar system. When we hear the words solar system, most of us immediately picture that familiar lineup of planets orbiting neatly around the Sun, from Mercury all the way out to Neptune. Between Mars and Jupiter lies the asteroid belt, and beyond Neptune we find the Kuiper belt, home to icy worlds like Pluto and Eris. It might seem like there's nothing else past that point. But in reality, that's where things truly begin. Just beyond the Kuiper belt lies a region called the scattered disk. Out there, icy objects travel along tilted, elongated orbits that stretch far from the Sun. This mysterious zone might extend out to a staggering 93 billion miles from the Sun. For context, it was only recently that the legendary Voyager 1 spacecraft, launched back in 1977, passed the 15 billion mile mark. Today, Voyager 1 still holds the record as the most distant human-made object in existence. And yet, even this remarkable machine is barely clinging to the shoreline, while the vast cosmic ocean lies far beyond its reach. In that realm, the faint glow of the planets disappears, dust no longer drifts, solar winds go silent, and near-total darkness takes over. Somewhere out there, hidden in that endless night, lies what scientists believe to be the elusive Oort Cloud. What is the Oort Cloud? The Oort Cloud is a hypothetical, spherical shell made up of icy celestial bodies, completely surrounding the Sun from every possible direction. We've never been able to observe it directly, but everything we know about long-period comets strongly suggests that somewhere out in the depths of space, there's a massive ancient reservoir holding the building blocks of the early solar system. Scientists believe the Oort Cloud has two distinct layers. The inner region, often referred to as the Hills Cloud, is thought to stretch from about 186 billion miles to as far as 1.9 trillion miles from the Sun. This inner layer is believed to have a flattened disc-like shape. The outer layer extends even farther, reaching out to an estimated 9.3 trillion to 18.6 trillion miles from the Sun. That's roughly 2 light-years away, or about half the distance to the closest star, Proxima Centauri. Unlike the inner region, the outer cloud is thought to form an almost perfect sphere. Based on current estimates, the Oort Cloud may contain several trillion objects, many of them over half a mile wide. But the distances between these objects are absolutely enormous. On average, they're separated by tens of millions of miles. So why is it that we still haven't been able to observe any of these objects directly? The reason is surprisingly simple. First, these bodies are incredibly dim. Second, they're unimaginably far away. That's why, even with today's most powerful telescopes, spotting something that distant is still beyond our capabilities. But just because we can't see it doesn't mean there's nothing there. So what first led scientists to believe that a massive cloud of ice and rock might exist far beyond Pluto? The answer, as it turns out, is pretty straightforward. Comets. Comets are like wandering travelers that pass through the inner solar system, trailing long, glowing tails of gas and dust behind them as they soar through space. But every time they swing close to the Sun, they begin to break apart. Their ice evaporates, their orbits shift, and many of them eventually shatter into pieces. If comets had been orbiting inside the solar system like planets for billions of years, they would have completely disintegrated by now. And yet, every few years at least, astronomers detect a brand new comet with their telescopes. This means there must be a hidden reservoir somewhere, constantly supplying fresh comets to the solar system. That idea first took shape in the middle of the 20th century. In 1950, Dutch astronomer Jan Oort analyzed the orbits of hundreds of comets and noticed a fascinating pattern. Many of them had enormous orbits stretching tens of thousands of astronomical units, and they were making their very first appearance. In other words, these comets came from a distant region where the sun's gravitational pull barely reaches, and they all seem to originate from the same far-off source. However, their speed wasn't great enough to escape the sun's gravity entirely, so they didn't break free of the solar system forever. This means they aren't visitors from deep interstellar space. These comets are ancient fragments of our own solar system, flung out billions of years ago. And now, something has nudged them with just enough gravity to send them falling back in from the edge of the void. This led Oort to realize that somewhere beyond the orbit of Neptune, there must be a vast storage zone holding cometary material from the very birth of the solar system. Later on, it was discovered that an Estonian astronomer named Ernst Öpik had proposed a similar idea even earlier. Ever since then, the Oort Cloud hypothesis has remained the most compelling explanation for the origin of long-period comets. These are the cosmic travelers that return once every tens of thousands of years, carrying with them matter older than Earth itself. How did the Oort Cloud form? To understand where the Oort Cloud came from, we have to go all the way back to the birth of the solar system, around 4.5 billion years ago. At that time, a massive protoplanetary disk made of dust, rock, and ice was swirling around the young sun. Out of that chaotic mix of matter, the planets, their moons, the asteroid belt, and billions of smaller objects were gradually formed. As Jupiter, Saturn, Uranus, and Neptune grew into the giant planets we know today, their immense gravity began to shape the solar system in two major ways. On one hand, their gravity pulled in surrounding debris, collecting new moons and small bodies. On the other hand, their gravitational pull acted like a cosmic slingshot. Whether an object stayed or got launched depended entirely on the speed at which it approached the planet. If its speed was below the planet's escape velocity, it either crashed into the planet or was captured and remained in orbit as a moon. But if it was moving faster than the escape velocity, the planet's gravity would hurl it out, flinging it beyond the known orbits of all the planets. After billions of such collisions and gravitational encounters, the inner regions gradually cleared out their excess debris. Yet some of the objects that got flung away didn't completely escape. They ended up at the very edge of the sun's gravitational influence, too far to fall back, but not far enough to break free. Over time, these scattered bodies were nudged in all directions by the tidal forces of the Milky Way and the random passage of nearby stars. And from that once flat protoplanetary disk, a massive spherical structure slowly emerged, the Oort Cloud, silently orbiting the sun from a distance of several light-years. Some scientists also believe that, back when the sun was still part of a young cluster, it may have captured icy bodies from its stellar neighbors as well. And so, over millions of years, this immense, nearly invisible shell of frozen relics was born, a kind of icy tomb that holds the oldest memories of our solar system. But can we really be sure the Oort Cloud even exists? Technically speaking, no. After all, we've never directly observed it. And that brings up an important question. Where exactly are all those long-period comets coming from? Those that fly in from every direction, circle the sun, and then disappear once again into deep space. If they're not coming from the Oort Cloud, then what other explanation is there? We would need a completely different theory to explain their strange orbits and how they're distributed across the sky. But so far, no such alternative has ever been found. The Oort Cloud isn't a rigid belief. It's a practical model that perfectly explains the evidence we've gathered. It ties together the movements of comets, the evolution of the solar system, and the gravitational influence of distant stars into a single coherent picture. So while we haven't seen it with our own eyes, the Oort Cloud remains the best explanation science has to offer. And maybe one day, a powerful new telescope will finally detect the faint glimmer of those icy wanderers, confirming once and for all that this mysterious cloud is real. Beyond Neptune's orbit. The Oort Cloud is like the solar system's invisible shadow, marking the boundary between everything we know and all that still lies beyond our reach. Until we can send a probe that far, we won't be able to observe it directly with telescopes. And yet, nearly every observation we've made, from comet movements to orbital paths and celestial distribution, points to the existence of the Oort Cloud. It's the oldest archive in the solar system, a silent vault holding frozen fragments from the dawn of our cosmic history. Locked inside those icy bodies may be the very materials that once gave birth to the planets, and eventually to us. And maybe, someday, one of humanity's future spacecraft will cross that dark frontier and capture the very first ever images of particles from the Oort Cloud. For now, the Oort Cloud remains something almost poetic, a symbol of where knowledge ends and mystery meets. We've come to understand how stars are born, and we can even measure black holes. But when it comes to what lies beyond Neptune, the last known planet of our solar system, we're still mostly in the dark. In fact, we're not even completely certain Neptune really is the last planet. Some scientists believe there could be a ninth planet out there, possibly 5 to 10 times more massive than Earth. The strongest hint of its existence comes from a group of distant icy objects beyond Neptune that all seem to follow strangely clustered orbits. Based on calculations, this possible planet would follow a long, stretched-out orbit tilted about 15 to 25 degrees from the plane of the solar system, taking thousands of years to complete a single trip around the Sun. But that's a story for another time. If you found this video interesting, don't forget to give it a thumbs up. And if you haven't already, make sure to subscribe to the channel. Thanks so much for watching. Until next time, take care.